All right, thanks everyone for joining us today. This is a webinar series that's a collaboration between Alabama Extension and the Alabama Nursery and Landscape Association. We host these webinars the third Thursday of every month. If you miss one, they're all recorded and we have posted them on the ANLA YouTube page. Today, our speaker is Dr. Steve Lee. He's an associate professor in the crop soils department at Auburn University. He's also the extension specialist covering weed management throughout the state. And he's also known nationwide as one of the top researchers dealing with drone aerial applications. So that's what he's going to talk to us today about is using these aerial drones in nurseries. So thank you, Steve.
Yes, sir. Thank you for the intro. Are you able to see my slides? Is it looking good?
Yes.
Okay. All right. Good. Good. All right. Appreciate for the introduction and thanks for the invitation today. Apologize for running a few minutes late. I'm doing the webinar from my truck, so finger crossed my internet connection or cell phone hotspot is going to work fine for the talk. I won't be able to turn on the camera because I'm afraid it may overwhelm the cellular hotspot. So hopefully my video will play fine. But yeah, glad to speak to the group about some of the work we have done and also the current regulations regarding spray drone. It's a very popular tool these days. Nationwide and even globally as well. So the adoption is almost exponentially increasing in the last couple of years, and we don't see this trend stop or slowing down in the near future. So I think I'm responsible to say in the next at least 2 to 3 years, spray drones will still be rapidly adopted by farmers and in ag area, as long as there is no major policy change or supply chain issues. So a quick summary of what these spray drones can do. You can spray your traditional fungicide, insecticide, herbicide, plant growth regulator, liquid fertilizers with it. But at the same time, spray drone also come with a dry tank that you can spread a dry product. For example, dry fertilizer, dry granule pesticide. For nursery, it's the granular herbicides. Also, cover crop seeds. It can be used in many different type of crops, row crops, horticultural crops, perennial crops, and also it's a very useful tool in the non-crop area for general vegetation control. You can spray places like roadside, railway, power underneath the power line, spray pond, spray river, control the aquatic weeds, spread seeds on food plots, even do mosquito control, paint the greenhouse for shade, this type of operation. Usually when we run spray drone operation, you will need to build a trailer. And the formality of the trailer come with all different types, so many different designs. I have seen a lot of really impressive ones over the years. And in the spray drone trailer, you will need to have the generator running to charge battery because you are charging battery constantly when you run spray drone operation. And typically you need to have the mixing tank or the reloading system if you're spreading cover crop or granule pesticides. So there needs to be a mixing or refill system on the trailer as well. So the trailer goes around the job site to reduce the ferry time of the spray drone. So the goal is to minimize the empty ferry distance and the time and let the spray drone get back to work as soon as possible. All right. Hey, is everyone still hearing me okay? I'm just making sure the internet is still working for me.
Yeah, you're coming through fine, Steve.
Okay, all right, that's good. That's good. I'm a little concerned about the signal, but if signal become a problem, please let me know. All right. All right, so these are some of the trader designs across the country. All right, so this is a common way to spray container plants in nursery. And we took this picture. This is actually a video, so I don't know how well the video is going to play, but you can see the point. All right, a person wearing a Tyvek suit and a respirator, wrapping the hose, a long hose around him, walking down the alley to spray the plants with whatever pesticide or foliar fertilizer that need to be applied on. All right. If you don't know what he's doing, you almost feel like this guy is power washing the plants some way, somehow. So the GPA is very high. And also in windy condition, it also drift as well. So drift is not only limited to the sprayer, the water hose can drift too. The other problem is it's a slow process when you spray in this manner. All right, this person have to wrap the hose around him, drag the hose all the way down to the other side of the alley, and then spray back, move the hose to the next alley, drag the hose down, and repeat 1,000 times in a day. So obviously, it's a slow process, you know. So I don't know how well the video is going to play with the cellular internet, but hopefully, it kind of demonstrate the point. So we want to replace manual labor. We want to decrease the reliance on manual labor. And then this is where the drones come in play. They're not that expensive, but they work really well for small production. On real large areas, say row crops, this could be several thousand acres, continuous acre. Airplane is the best, or ground rigs. But for nursery, most of the blocks are a couple acres in size. Sometimes may not even be 1 acre in size. Current spray drone with 40, 50 liter or 60-liter tank, that's anywhere between 10 to 15 gallons, per tank is a very sweet spot for us. We don't need the drone to carry a lot of material and fly a long time because of the production setting. This is how the spray drone spray the same block, and hope you can see the propeller downdraft. Propeller downdraft is the air or the wind produced by the propeller. It is definitely blowing the pods very hard and blowing, the chemical in there. That was a windy day when we sprayed, so the drift was a problem. But if you spray in a fairly calm day, say if this is a fungicide or insecticide, the goal is to use the propeller downdraft pushing force to shake the plants, to make the small droplets hit backside of the leaf to control the aphids, the mites, and disease, and hopefully penetrate through that canopy with the help of propeller. All right, so that's the result of the application at Martin's Nursery in Mobile. So drones sprayed a 15 gallon per acre. It was about 8 feet above the canopy. If you want more propeller downdraft force, you fly closer to the canopy. If that's too much wind, it's kind of blowing the pods away. I'm sorry, I have a conference call now. I told Ali about this. I'm not available from 10 to 11. Yeah, sorry. Yeah. Sorry, they're asking me to do the next group, but I told the organizer I'm not available for this hour. Sorry about that. So you can see the water sensor paper we placed in this field, in this crop. So we put the first row of the water sensor paper facing up. So that's that all those papers were clipped on top, facing up on top of the leaves. The second row of the water sensor paper was facing down, so they were clipped at the bottom of the leaves. They were facing the growth medium, like the organic potting soil. And then the third row of the water sensor paper was placed on the growth medium, literally on top of that organic soil. So I hope I explained this clearly. And at the 15 GPA with fairly strong propeller downdraft, the turbulence created by the propeller, we saw fairly good canopy penetration. And also the second row of the petri dishes or the water sensor paper make me excited because we hit the back side of the leaves. We hit the bottom of the leaves fairly well. That's what we want to achieve with a lot less water per acre, and higher accuracy. The other thing that might be useful is spraying in a shade house using a fairly small drone, and in this case, we were flying a small 10-liter drone inside a shade tunnel to spray or spread on these plants. And I have been told this is not possible these days, to use any type of equipment to spray inside the shade tunnel. So it's all done by hand, which is a lot of labor, So that was the testing the other day at the Flowerwood Nursery. So this could be a potential usage for the equipment. All right. So we're done with the liquid part of the business. Now we're moving to dry material spreading. So these are some of the videos I took with the bigger T40 drones spreading cover crops after corn harvest. They can spread fairly well in terms of uniformity.
Hey Steve, just so you know, none of the videos are actually playing, but we can see the screen. And
okay,
almost like clips, but it's not really playing, just so you know.
Yes, sir. Yeah, thanks for letting me know. That's the internet issue. And then to mitigate that problem, I will send you, Jeremy, I'll send you the link to download the whole slides. So whoever wants to watch the video after the webinar will be able to get a copy of the slides along with the videos so they can watch it. Hope I can just demonstrate the point a little bit better. All right. So in terms of dry material spreading, I know this is where the interest is at from the nursery growers, from the container plant growers. All right. So so that day at the Flowerwood Nursery, we appreciate the host for helping us out with the testing. So they have a one worker demonstrated how to use a hand crank spreader to spread granular materials. And we captured the materials using 5-gallon buckets and also tested the T40 for spreading uniformity. So what we did is we just lay out a bunch of 5-gallon buckets and we put weight inside the bucket. The buckets were placed every 1.5 feet, every 1.5 feet away from each other. All right. We let the person spread with one pass, and then and also at the other side at Martin's nursery, the workers spread two passes. So we measure the spreading uniformity and the target and the actual rate of hand spreading versus drone spreading using one pass or multiple passes. And then we weighed the material that we collected from the bucket. So this is how we collected the data. All right, real quick on some of the data we collected. So this is from a Flowerwood site. Drone spread the granular herbicides at a 200 pound per acre target rate. This was only one pass spreading, and the drone was flying right on top of 7.5 feet mark in the transect. All right, so the transect runs one direction. Drone pass was perpendicular to the transect, and the drone flew right over the middle of the transect, perpendicularly to the transect, collection transect. All right. So drone flew at 7.5 feet. We can roughly see a bell-shaped distribution in the first run. The second run is not quite obvious, but I have a feeling after I look at the curve, after I look at the bar graph here, I think the drone could spread wider than 15 feet, and that was confirmed in our cover crop spreading test. We need to run more pattern testing on the drones to understand what parameters will work the best. But based on our current results on cover crop spreading, T40 can easily spread 20 feet without too much issue. So we probably need to increase the transect or the width here to 20, even to 30 feet to capture a whole swath. So a lot of people ask how wide this thing can spray or spread. So the target rate was 200 pounds. The actual rate we called was anywhere between 175 to 183 pounds per acre. So that's not too bad. And you can actually calibrate the drone and offset the difference. So it will be within 10% or even 5% of the target rate. All right. So for this worker to spread by hand crank spreader, uh, it, there's no way he can cover the whole 15 feet transect in one pass. Actually, this person walked on the 9 feet mark. This is why there's nothing collect at 9 feet, because we have to remove the bucket at 9 feet for this guy to walk through. And then we only caught the granular herbicide material in 5 buckets instead of all 11 or 10 buckets. All right. Versus the drone, we caught material in all buckets. Here is very limited. So the hand spreader has a very narrow swath, and the uniformity is also pretty terrible. It's also pretty terrible. So the target rate was 200 pounds per acre. We only caught not even 100 pounds per acre in this case. So which means this guy literally have to spread twice to get to the target rate. That will just decrease the efficiency by 100%. All right, the graph here shows the coefficient of variation, basically, or CV. Basically, CV measures the uniformity. The higher the CV is means the more variation we observed in our samples, that we collected from those buckets. 80% CV means if the target rate is 100%, the actual number we caught in the bucket could range anywhere from 20 to 180 pounds. So the higher the CV, the worse uniformity it is. All right. So we can clearly see that drone spreading runs were less than half of the CV than people, which means a lot more uniformity and a lot faster as well. So this was based on just one pass. So the next day we went to Martin's site and we did a 2-pass spreading. All right, you can roughly see where the drone fly in this case. So the drone flew 2 passes. It flew above the 0 feet mark on the transect, and it flew again over the 15 feet mark in the transect. So it flew twice and overlap in the middle. All right, in this case, this is why the bars look more even across the transect. So target rate was 200 pounds. We called 157 pounds. Probably can calibrate the machine just a little bit better to be more accurate. We were kind of in a rush that day, but calibration can be done, at any time when you do the real job. So for people or for hand spreading 2 passes, this time the uniformity was improved for sure. The actual rate was similar to the drone. It's about 150 some pounds. So it wasn't as accurate as we would like to. So as you can see, the problem is twofold. It's, one problem is how accurate is your rate. You're shooting for 200 pounds. Are you really applying that much? The second issue or second aspect is the uniformity. Did you really spread the material evenly across the field? And then we know the less target rate you're shooting for, say you're spraying 10 pounds per acre versus 100 pounds per acre, spreading 10 pounds per acre evenly across the field is 10 times more difficult than 100 pounds per acre. That's just common sense. All right, looking at the coefficient of variation or CV for 2 passes between drone and the people, again, still at least 50% reduction of the spreading variation and at least twofold increase of the uniformity by drone in this case. That's 2-pass spreading. All right, at the Flowerwood site, the third testing, we tested drone and the people on multiple passes because both method was used on production blocks. So we spread a little wider area. And also Dr. Pickens brought a lot of small buckets. They're kind of like the buckets people used in the like strawberry picking, in farmers market about that size. So he put a small bucket underneath the crop canopy to capture the granular herbicide that we spread. This time, we just kind of simulated real world action, instead of a one pass, one transact method. This is multi passes in a realistic fashion. All right. So the graph on the left shows the target rate and actual rate we caught. The target rate was 100 pound per acre this time. Both drone and hand spreader was kind of similar. Hand spreader was a little closer to the target rate. Again, this emphasized the importance of calibrating your drone and testing for output to make sure you stay close to target rate as best as you can. We probably could use a little bit more effort to make it accurate. And also, the second graph shows the coefficient of variation again. The lower, the better. All right. In the real production blocks over several acres, the drone's accuracy, or I shouldn't say accuracy, the drone's uniformity again was significantly better than hand spreader. Okay. And also we use T40 to spread about 9 to 10 acres, something like that, at 100 pound per acre on production blocks. It took roughly about 45 to 50 minutes to finish those acres. And that's including the refill time, coming back, land refill, swap battery, and let it go back. That includes all the refill and landing takeoff time. So normally speaking, to spread a 9 to 10 acre, this could take one worker a whole day. If this is a nice day that doesn't rain at 2:30 in the afternoon, to finish. So a whole day of work can be done within an hour with much better uniformity with a spray drone. All right, still, there are so many questions need to be answered. We have not done a uniformity and spreading testing to fine tune the flight and spreading parameters. We will just go by gut feeling in those initial testings. So, we should use some more effort there to figure out the best way to spread these granular products. Also, at the same time, because the drone can spread 1 acre so fast, like, within 2 minutes, something like that, usually 2 to 3 minutes. So can we spread on wet foliage in early morning, and then after 2 minutes, we turn on irrigation immediately to wash off the granular herbicides to avoid a leaf burn? And also this will allow us to start operation way earlier than 9:30 or 10 o'clock after the foliage dries out. I don't have the answer. This could still be risky, but Jeremy and I talk about this, and we may still like to test it, later this year, if possible. And also the third question we need to answer is, can we achieve similar efficacy of insect and disease control with only 10 to 15 gallon per acre versus 100 plus gallon per acre, like the guy was power washing the plants with a hose? How does the efficacy compare between the two methods? We don't have any data, and that just need to be tested. And also the last one is just a pet project. I'm curious if we can use the RGB scouting drones, which are getting more common and much cheaper than what it used to be, to actually take the image and use some commercial softwares to count the pots, so you can calculate, or you'll be able to assess the inventory in your nursery. I mean, if that's possible, then it may not be 100% accurate, but let's just say if it's 95% accurate, you have 100 pots in this tier, the drone counted 95 pots. I mean, that's still better than, eyeballing it, So I don't know if that's possible or not, but there are several software I like to try for stand count in row crops. And I've been told one software or one algorithm can actually count Christmas trees fairly accurately. So I would like to try this on nurseries, perennial nursery plants or container plants, and see how accurate it will be. All right, talk about all the field work. And we have to also mentioned that you cannot just buy a drone and start to spray or spread however you want to. That's illegal operation. If you get caught, there will be a lot of fine and potential punishment come with it. So for a legal operation, it takes quite a bit of effort, time to get all these approval. I highly recommend hiring aviation attorney to file the FAA paperwork if you do not have any aviation regulation or aviation law background. It's just too much for average people to tackle those exemptions. So you need to register your drone with FAA. Any drones heavier than 55 pounds will need to receive an N number similar to an aircraft. All right. And then you will need to have FAA Part 107, the remote pilot or drone pilot license. And then the most difficult one used to be the most difficult one. Now it's a lot easier to get is the Part 137, which is the crop dusting license. This license allows you to spread chemicals, fertilizer, seeds aerially with drone or airplane. There are some additional FAA exemptions you have to file in the section 44107. Your aviation attorney will tell you exactly what those exemptions are. You need to get a state area applicator license if you run commercial operation. For private applicators, Alabama may still allow private applicator license to be used on drones, but it's a good idea to contact Montgomery and make sure that the applicator license will be valid for drone operation. Highly recommend the insurance to cover liabilities. Bad things can happen. You don't want to wait until something get damaged, somebody get hurt, and then realize you need to buy insurance. Also, I need to focus on the last two talking points. You need to have the approval from EPA and Alabama Department of Ag or another state's Department of Ag. You need their approval to use or spray pesticide with the drones. I will come back to this point in the next slide. Also, you need additional approval to fly in controlled airspace and a military operational area. So what do you mean by you have to get EPA or state approval to spread a certain pesticide that you want to use? All right, it goes back to the label. I pull up two labels to use as examples. The first one is Spectacle. It's no longer a Bayer product because Bayer separated their environmental science group out. They sold it out as a separate entity. It's called Enview now. So Enview owns Indaziflame or Spectacle label, and it's a granular for Nursery. I've been told it's a really good one. All
So
right.
this would be,
So
just for everybody's information, this is Moringo. The same thing as
this
Moringo,
is
same
Moringa.
label.
Okay. Oh, good, Jeremy. I appreciate it. Yeah. Yeah, I don't know the trade name that well for this, but Indaziflame is a great compound for turf, perennial crop like fruit tree, blueberry, and also in nursery as well. It's a great herbicide for those areas and a pasture, hayfield. So if you look into the label clearly says do not apply using aerial application equipment. All right, that one bullet point is enough for us to forget about it, at least for right now. This is a clear example to show that you just can't spray or you cannot spread this product over the top of crop with a drone or airplane because the label doesn't allow it. All right. In the other case, in this for this one OH2, so this is a mix of oxyfluorophane and pendimethalin, granular herbicide. So in the label of OH2, it says apply product with a properly calibrated rotary spreader that will assure accuracy, even particle distribution. And then the second statement is really exciting. Product can also be applied by aerial equipment. So aerial application is approved. So this one gets a green light from EPA and the registrant, chemical registrant, to allow us to be used, or to allow us use it with a drone or airplane. All right. So this one, yes, you can spread it with a drone. So make sure you read your label, you check with Ag, and then make sure that you are able to use the drone to spread or spray specific product. You know, the label has to allow it, and also the Department Act has to allow you to utilize that pesticide according to the label, because the State Department Act can also ban certain operations or revise certain label. They can further restrict the label if needed. All right, aerospace. This is mostly a new things for the audience of the webinar, but it's also an important one. All right, we cannot fly drones anywhere we want to, anytime we want to, for simple reasons: airport and control airspace. You can buy as a many acre land as you want to on the ground, but do you also buy the airspace above the property? The answer is a firm no. You do not own the sky above your property. So this is why you need to pass the Part 107, FAA Part 107 test, because Part 107 test heavily focus on aeronautical charts and how to read these maps, the knowledge of airspace, where you can fly, where you can, this type of stuff. There are several apps you can download from the App Store, to assist the decision. So it'll find your location, or you can drop a pin somewhere. It'll tell you what type of restriction for that specific location is going on for right now. All right. If you look at the Mobile, all right, there are two big circles here, two airports. And then the blue line means anything within the blue line is control airspace. You cannot fly anything, any drones at all, without receiving the approval of the airport and the FAA. All right. So if your operation happen to be inside the circle, you need to file special request to FAA and also talk to the airport control tower for your operation. Make sure they are on board, they're okay with you to fly at a very low altitude and only stay within your property, so that doesn't pose any risk to the airplane. And also the other thing we need to pay attention, look at the picture on the right, is the special military operation area. We do have a bunch of Air Force base in South Alabama, and the Florida Panhandle. So this one I used in the example was posed by the Abilene Air Force Base in Pensacola. All right, within the yellow line, it's the military operation zone. If you want to run drone flights on regular basis, you will need to speak to the traffic control of the airport, in the base, and also let FAA know to request approval. Eventually, you will get the approval. It may take a month or two. Maybe now it's getting faster, but definitely do not fly commercially all the time before you get those approval, because if something happens, the consequence can be really ugly. All right, that's all I have to say. I may present way longer than I promised. I apologize for going over time. If this thing has to be done like 10 minutes ago, but I put my contact information here. If in case anyone have questions, I want to further discussion, and I will send the slides or the link to download the slides and the videos to Jeremy and Russell, so they can share with all the participants in case somebody wants to watch the videos. Yeah, that's everything from me today. Hope the internet was mostly working, for you to hear what I was talking about.
Yes, you came through fine, Steve. Thank you for participating in this today. And right now, we'll open up to any questions from the audience.
All right.
Well, I'll start off with one just comment is talking with the Department of Ag. They're going to let us kind of go through the labels and check to see if it would qualify to be used for drones and give their okay or not. And so sometime, hopefully this summer, we'll have a list of at least pre-emergent herbicides that you may be able to use with these drones. The one where the label language is not limiting its application with drones.
That's a good point to bring up. And also I have expressed this concern to Enview because they own the Indazaflame label. Um, so they are interested in the drone applications, and they want to work with the growers to expand the label. So I told them, as long as you don't say do not apply aerially, and then that will provide us, enough gray area to operate with at this point. Yeah. As long as the label doesn't say do not apply aerially, you'll be okay using the drone to spread it. That's the general consensus.
We've got a question in the chat box from Daniel McMillan. I have had questions from nurserymen around ant bait. The customers I have want to spread it on rows, but the application rate extremely low. Is this possible by drones? So, Steve, the application rate for the granular
Mhm.
ant bait is around 1.5 to 2 pounds per acre.
Yes, sir. That rate is not possible to spread by itself. So the alternative is put something else with it. For example, some I don't know, fertilizer or
Kitty litter, maybe, or
inert ingredient. Yeah, something like that. And then spread at a higher rate, At least you need to get to about 20 to 30 pounds per acre for you to spread that stuff evenly across the field.
Steve, can you talk a little bit about, the first time we were trying the drone out,
Mhm.
and we had some blowovers because our plants were a little light and we had the drone too low, and just kind of
Yeah.
talk about that a little bit.
Yeah. Yeah, that's why I feel bad, about internet connection. You won't be able to see the video. Yes, if you're able to, you can see the wind is blowing the leaves and the pods all over the place. And then the lesson we learned from that first attempt at flowerwood is before you spray with the drone, you want to irrigate the pot because the pot that day was remember, Jeremy, was like a middle of the afternoon, kind of hot, and they were a little dry, so they get blown over a little easier. So I think irrigate the pot maybe needed, and also we can play with the flight parameter. If you don't want strong propeller downdraft, you can fly a little higher, and also you can fly a little faster as well to mitigate that. Yeah.
Yeah, it seemed like we went just a little bit higher, and I think if the
Yeah.
containers had been, it was earlier in the morning when they still had some weight to them, it wouldn't have been a problem at all. But they were some top
Mhm.
heavy, 1 gallon, kind of dry containers, and we were picking up a lot of plants.
Yeah. That's a good point. Yeah. And also different size of the container will play a role as well. I think the container we tried was 1 gallon, looks like
Yeah,
that
that's
day.
right.
It was like 1 gallon. Yeah. If you have bigger plants using 3 gallon or even 5 gallon, they won't be easily blown over compared to the 1 gallon.
That's right. Steve, how long does it
Yeah.
take to recharge a battery?
If you have a bigger generator, let's just say 12, 13,000 watt, with 9,500 watt running, those type of generator comes with 240 volt and a 50 amp plug. Using that plug, you can charge T40 battery from almost 0% to 100% in about 10 to 12 minutes, you know. But most of the time, when you finish one tank load and the drone fly back, you shouldn't use that much of battery. A lot of time when the drone comes back, I still have 30 to 40% battery left, And then if you swap the battery and charge this 30, 40% full battery, it will only take about 5 to 7 minutes, something like that.
Right. I got you. There's a question from Daniel McMillan. Have you used
Mhm.
multispectral drones for inventory and plant health analysis? I will say, Steve was talking about
Mhm.
doing this, and but there's also been some work pretty extensively with Jim Robbins at Arkansas and another collaborator in Maryland. I'm not sure their status with it. We also have a guy working with a ground-based drone system to do inventory analysis, but it's definitely possible. As far as plant health, that there has been some work done on that as well.
Mm-hmm. Yes.
Steve, I need to get you connected. There was a researcher at Purdue University that was doing some in greenhouse that was using cameras like the Raspberry Pis, little cheap cameras mounted to irrigation booms, checking germination, but they were also measuring the color of the leaves to see how much nitrogen was in them. Now, those are a lot closer than would be with the drone, but he may be somebody that you could collaborate with to at least see what he's already done in that arena.
Mm-hmm.
There's
that's
comment.
a good comment.
There's a comment from Tyler Duck, Flowerwood. He's saying his holdup has just been waiting for approval from Department of Ag. So the Department of Ag is okay with this as long as the label, as long as you have all their permits, and the label allows it. And so, again, we're going to go through those labels. There are some companies, there's some products out there that are ready to go right now. Several of OHPs. I haven't been through all the labels yet, but there are products you can use right now. And like I said, Steve and I will go through all that and hopefully have a list pretty soon.
Yeah.
Steve, we got a question. How would you go about the application exclusion zone using drones? And I don't know if that's a worker protection standards deal or what.
It sounds like he's talking about no spray zone when you map a field. I don't know if that's what you're asking or not. If not, you can type a little bit explanation here. But if you're talking about like a no spray, the no spreading zone, yes, you can easily mark off those area in initial mission planning. That's very easy. You can do it on the controller, on a drone controller, or you can do it on computer using the software from the manufacturer as well. So that's not difficult. Also, a follow-up on the multispectral drone for plant health analysis. That's gonna be a little bit difficult with the drone because the altitude that we're flying, ground-based sensors will be better fit for that regard, because the resolution is a lot higher where you're only like several feet off the ground versus 200-300 feet off the ground. You can see things a lot better with a ground-based sensor. But the reason why I say counting the inventory, counting pots with a drone is just because when you fly to 200-300 feet, it's very efficient. And also we may have enough resolution to see 1 gallon pots fairly clearly at that altitude. This is why I said counting pots is more doable for the drone, versus plant health analysis. Oh, I'm sorry, he said applying pesticide worker and driving around. Well, that's a label question. You have to check the label to see, what are the specification about people getting back to the treaty area, how they drive by, things like that. But the general recommendation is when you spray and spread with a drone, upwind side is not a big deal, but downwind side, you don't want any people to present. So it's a big thing for the drone operators to plan the mission, watch out for the wind speed, wind direction, so their people, their crew and workers don't get sprayed on. Although we do get sprayed on sometimes, I have to say that, but try to minimize that as best as you can. Yeah. Upwind side is the best. And in nursery world, because I've been to a few nursery, thanks to Jeremy, getting in touch with the guys. So in the nursery world, it shouldn't be too difficult compared to row crops. You can always stand on the upwind side when you do the operation. And most of nursery are fairly flat because of that.
Yeah, I think there's some newer regulations with WPS that are pretty specific, but it's we'll have to look into that too. But Steve, on the I'm not super familiar with those exact regulations. But we'll try to get some more info on that. But yeah, definitely.
Yeah.
Wind direction is important.
Yeah. And also the worker mixing the chemical for the drone or dumping the chemical into the hopper, into the dry tank, they need to wear PPEs. And particularly the dry material, because the dust, coming off the material and can easily be breathe into the lung. So that respirator is going to be needed, at least a mask.
So there's another question in the chat about, how often you need to clean the drones. I mean, are you using compressed air, kind of blow them off, soap and water? Like what are your recommendations based on whether you're a wet or dry apply?
Yes, sir. Yeah, great question. Drones are all water proof, well, to a certain extent. You don't want to use the power. You don't want to use equipment to power wash the drone. Power washing is too much of pressure that can potentially get into the electronic parts. Just rinse the drone with a hose, it's just fine. But periodically, you need soap and scrub to get oily residue off the drone. That's mostly because of the spraying. If all a drone and you just spreading granular products, then it's gonna be relatively easy. Just rinse the drone, rinse the surface, and then you can clean out most of the dry material at the end of the day fairly easily. A good question. Don't power wash the drones; they don't like it. Other than that, it'll be all right.
Do we have any other questions from the audience?
Oh, the other question we got back in those visit Jeremy was about the mapping. Some people are concerned that they have to map the blocks all the time, and then you got a question from new operators, or people interested in drones. For commercial nurseries, as long as you don't change your blocks all the time, you only have to map it twice. You only have to remap a field when something is changed. For example, you build a road or irrigation is changed or something like that. Yeah. Mapping is usually a one-time mission.
Well, I think that's all the questions we have. And Steve, we're grateful for you, your time and presenting all this information. It was a great presentation. And if anybody has any questions, please reach out to Steve or myself, and we'll be happy to help. Thank you, Steve.